Ahoy mateys, welcome back. In the last video, we finished chapter 3, which compared deployment to computer memory. And now we're moving on to chapter 4, which is the Nix expression language. I'm continuing my series here of talking about Elko Dolstra's PhD thesis named the Purely Functional Software Deployment Model. 4.1 motivation. The Nix expression language is a simple, untyped, purely functional language. It is not a general purpose programming language. Its only purpose is to describe components and compositions. A purely functional language gives us a clean component description formalism. The notion that components can be produced by functions that accept values for variation points of the component is much more flexible than, say, a language that binds such variation points using global variables. He then gives an example of compiling a library named aterm using purely functional semantics, and then compares it against using a makefile that has a global variable that would control this maximal sharing the variability that he wants to give it. And then he gives an example of using a makefile is not imperative, but then he gives an example using an imperative language to do the same. And I think in this case, he this is a PhD thesis, so he's been thinking about this really hard for a year or two. I think he may have buried the lead here. He's trying to provide a system that does only one thing, which is let people specify a set of conditions that imply a particular end result, where that end result is a certain arrangement of files on the file system. He's making the assertion here sort of obliquely. He may do it in more detail later, asserting that the best way to do this is through a functional language. He wants to build two different variations of the same piece of software, one with maximal sharing true and one with maximal sharing false. And he says it's hard to do that when you have global variables laying around and you have to sort of have some external thing that changes the variable and builds it twice. Or in, something like Python or JavaScript or whatever, you have to build one and then build the other, and concurrency is hard. And but all this stuff is sort of in the weeds, I think, for the actual domain here. What he's actually getting at is he wants to provide something more akin to a configuration file that describes the outcome, and he wants to allow this interpreter to take that description and turn it into files on the file system. And in particular, one of the important bits of doing that is removing the responsibility from the user for the ordering the things happen in. Right. So I'm sorry I'm editorializing here, but the idea that this needs to be done purely functionally, I mean, it's fine that it's done functionally. It's just, it may not need to be the headline. It would probably, even if it wasn't the headline, it would probably still be done functionally. But the headline here is that we are providing the description of the system of an end result that we would like to the compiler such that it will do stuff for us, and we don't have to be in charge of certain aspects of it doing that stuff. So let's compare that to something like a makefile. A makefile has some of those properties. Foo depends on aterm, bar depends on aterm, and aterm does some stuff, but some stuff has an ordering in it. And of course, the things that this thing does, or it calls out the shell scripts, those shell scripts have ordering, so you could make that analogy between these two things. But the bit that the functional part helps here is this global variable. This max sharing thing doesn't need to be there, or it doesn't need to be in the environment. It doesn't need to be called twice, and the user can be blissfully unaware of the order that foo and bar wind up being built in. They don't need to know that they need to build foo and then bar. Similarly, here where we say max sharing equal true and then call foo and then max sharing false call bar, this may be a little contrived because, of course, really what you'd want to do is call foo aterm and pass max sharing equals bar as arguments to aterm. But the bigger point here is that defining these things, these foo and bar things, you're not in charge of how they get evaluated. You don't tell it to do foo first and then bar, or bar first and then foo. You just tell I want foo and bar. Here you have to know one way or another, whether there's globals or not. You have to know whether you're going to do foo first and then bar, whatever, unless there's another phase. And then, maybe there's another phase. You could imagine a system where these actions, calling foo with a term, calling bar with a term, did happen in a particular order, but they didn't actually do anything until you called some realized thing on some other object that represented the state of the system. And these things had the side effect of mutating that state. The case he's making here could be made a little clearer, or maybe I think the case he's making here is really in this one sentence. The execution order frustrates comprehension. Well, in a perfect world, you would have a configuration language that was completely comprehensible just by osmosis. You'd look at it and you'd be like, oh, of course, all these files are going to end up in these places. And in some cases, if it was something like YAML or a JSON file or something, with no conditionals and no imports and whatever, it could be that thing. And lots of languages try to do that. Like Python has a PyProject.toml that wants to represent all the things about how you should build this thing that will end you up with a package that can be installed. There are a bunch of conditions in there implied by sort of, version between this and this, and only on Windows, and et cetera, et cetera. And they're given as sort of, they look like just, the values of keys in a file. And there are no more general things to say this section applies at this time, where this time is defined by the writer of the configuration file. You just have to live within the constraints that are given by the person who wrote the parser and the evaluator of the TOML thing. In a perfect world, the language that we use here would be totally understandable. You just walk up to, just look at it and be like, oh, of course, all these files go here. In the real world, it's hard and it's difficult. And any language is going to introduce features like conditionals, like imports, and like assertions, data types, special behavior based on organization, and compound structures like lists and dictionaries and stuff like that. Any language is going to do that. So the more things you add to it, the harder it gets to understand. And this is what this bit of Nix, I think, is what people really trip over when they look at it. They first don't understand that the purpose of Nix itself and the Nix language. Well, first, I imagine that a lot of people don't understand that it's meant to not be a general purpose programming language. They think that somehow it's meant to, you'd be able to write a web browser or something like that. You can't. Second of all, I think they don't understand that it's meant to be more of a description of an outcome than it is to be an imperative programming language. And most people are just used to imperative programming languages: Java, Python, JavaScript, C, C++, Ruby, whatever. All those languages are totally imperative. And people are very, 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 very used to controlling the order in which stuff happens. And when they can't, they get very frustrated. He's of course steeped in this. He already knows this so deeply that it's so obvious that he doesn't have to write it down. You know what I mean? Like, it's so obvious to him that he doesn't have to write it down. But for most people that are not used to not used to it, the Nix language is totally incomprehensible. And it's because they don't understand that it's meant to be a description and not a set of steps, not a recipe. Right. And of course, there are other systems like Geeks, which use other languages. Like Geeks uses Guile to do all the stuff that the Nix does in the Nix expression language. An anti-pattern or an anti-goal for Elko in this thesis is to have everything done in this language. He's careful, very, very careful about circumscribing what this thing is good for. It's good for this description. It's not good at writing files to the file system. I mean, it does that, you know, in various ways, but it's not good at the things that Bash is good at. The imperative stuff, you know, do this, then do this, then do this, then do this. It's not good at that. But it's explicitly not meant to be. Now, Guile is really good at that because it's meant to be more general purpose imperative language. So the folks that want to use Geeks, they tend to not make the separation between these two things. They have a description language, which is in Guile, but then they also do the imperative steps in Guile in the same language, and they're interleaved together. I imagine that causes all kinds of weirdness when people don't understand where the boundary is between the two things. Maybe not. Maybe all the Guile people are brilliant and do not need a hard boundary between those two things. But I think in spirit, anyway, Elko's decision to do it this way is sound. I'm not a huge fan of this language, but the concept of doing this way, I am a fan of. I think it is the right split between these things. Okay, so he sort of goes off talking about why RPM sucks. Here might be a little in the weeds for this. Okay, so okay. So he's talking about laziness. So he's saying the language is functional. I think it would have been better to have another section up here saying this is a DSL, and it's a DSL for describing the outcomes. So, I mean, it does say that in here somewhere, but that really is the big deal about it. Saying one of the other properties of the language is laziness. It's possible to find large sets of components concurrently without having to build them all. And he gives this example here where he's got standard glibc, GCC, et cetera, set of Firefox in a recursive attribute set and hundreds more. And since the language is lazy, the right-handed sides of the attributes will not be evaluated until they're actually needed, if at all. So this means if we want to just install hello, only the hello value will be evaluated, although it might in turn require other values to be evaluated, such as standard half second on an Athlon XP 2600. Ooh, 2002. Nice. Yeah, he's saying that every attribute is lazy, you know, until you access an attribute in some other expression, it is unevaluated. Which is, yeah, I mean, it makes sense, you know, in this context. If, you know, you can, like I said, you can emulate this in any language. This is not a necessarily just a property of certain languages. It basically means don't use a bunch of language features. You know, if you were to do this, like I'm sure this is done in Geeks in a way that during this phase of operation, it does not do evaluations of certain things, and only when you call some build method or rebuild method or whatever on, well, function on, you know, the global data structure represents the build, will it actually evaluate this stuff and do the operations. But of course the problem is that people do that stuff. They you know, they don't respect the phases. They'll do some things that require ordering in phase one that break the assumptions of the thing that happens in phase two or something. And there are all kinds of just, you know, things behind the back of the presumptions of the writer of the thing that does this evaluation. So it is a feature of this language that it doesn't do things because it is not a general purpose language. It doesn't need to implement this laziness thing on top of a more general purpose sort of imperative language. It just builds it right in. Yeah. So he's saying here that building OpenSSL will only be built if SSL support is enabled, despite the fact that OpenSSL is always passed as an argument. So he's saying that in a non-lazy language, you wouldn't have to, you wouldn't be able, quote unquote, to pass in OpenSSL, because if you passed in OpenSSL would have meant that OpenSSL would have had to been built. But this is just not the case. This is just, you know, this is like you could represent OpenSSL as something that hadn't been evaluated yet and pass it in, and it would have the same impact. It's just that people would maybe evaluate it first. Maybe they pass in the evaluated one. You didn't want them to do that. You wanted it all to stay unevaluated, but God help you, they evaluated before they passed it in, and now what? So yeah. Okay, so syntax. I am not. All this stuff is just gobbledygook to me, and I am not that interested in parsing. Bacchus-Naur form, lexical syntax, context-free syntax, all this stuff. I don't think it's that interesting, and I'm not going to talk about it. The values associated with identifiers can be integers, strings, pass, and URIs. Those are the only types he's supporting. I think that's still true. It says that Booleans aren't even specified. They are built-in nullary functions. Okay. Expression can be enclosed in parentheses to avoid the normal precedence rules. The language has two types of functions. The first type of function takes a single argument, and that is its form. And this returns, that's the identity function. So if you pass in x, you get the x back. Of course, this style function is just a plain lambda abstract from the lambda calculus, as we will see in discussion of semantics below. Though the style only allows functions with single argument, then he goes on to explain this sort of functional programming mantra where you can always pass in a single argument and then get back a function that takes a single argument and then get back in another function that takes a single argument, and you can compose multi-argument functions from single argument functions. And most functional languages do that under the hood for you. Second style function definition, which we've seen in section 2.2, is more important in this language. It takes an attribute set and binds its attributes defined therein to local variables. Thus, x comma y, these are the arguments, and it will return the sum of x and y. Okay. So he's defining a function here that takes an x and a y, and it does concatenation of x plus y, and then the arguments he passes to it, where y is bar and x is foo, it will return foo bar. And well, I think what he's trying to point out here by this funky ordering of stuff is that the ordering of these arguments doesn't matter. The arguments, I should say these are parameters, these other things over here, these are not arguments. The arguments that he passes in, the ordering does not matter. Function calls written by juxtaposition. Instead of saying, func, open paren, arg, close paren in order to call a function, you say func space arg in order to call the function. And then these parentheses here allow you to control whether something is considered a function or not by the evaluator. He's got this with statement here where that just sort of puts y and x in the current scope. It makes more sense when this is not defined statically. It makes more sense when you pull it from somewhere else. But yeah, you can just say y here, with some expression, and then if that expression returns an attribute set, you can use the attributes from that attribute set in the block within there. Yeah, so he describes that here. Yep. Yeah, and one of the interesting things about this language is that unlike something like or a C preprocessor, imports can happen anywhere. You don't have to just import stuff at the top of a module. You can do it in a let statement, or you can make it an argument to a function or whatever. You can import anything anywhere. Okay, so now he's defining compound types. A list is open paren, element, space, close paren, not paren, bracket. They are not separated by an explicit delimiter. And so that's a list. And same thing for identifiers, A, B, and C in close brackets. When they're in these brackets, it is never considered a call to a function A with arguments B and C. It's always just individual elements inside the list. I would have put commas in there. I don't know. Well, whatever, man. I probably would have put commas in there. He talks about if-then statements, conditionals. Anyway, I think that's it for now. I will go on to section 4.3 in the next video, I suppose. Unless it's very, very boring. I haven't read it yet. Thanks for watching. Bye-bye.